This conference will now be recorded.
Okay, so let's go with smart discovery today. Guys, in the last session, I clearly given an introduction on ML, right? Artificial intelligence and machine learning, how it works. So how it is used in data analytics and in SAP Analytics Pro. So I clearly mentioned it. SAC has got inbuilt machine learning algorithms using which in BI you can do augmented analytics, in planning and predictive analytics you can do future predictions. Okay, now let's run some kind of a smart discovery on top of this data. Okay. So guys, in augmented analytics, the major option is smart discovery, guys. So a lot of people think so the majorly what we do in augmented analytics is discovery, data discovery. Okay. So as I mentioned, right, finding the hidden insights on the data and doing all the data diagnosis, right? So that is done through smart discovery. So the option that do all the data diagnosis here is smart discovery. So smart discovery is nothing but your data discovery powered by machine learning. Okay. So generally, smart discovery is applied on a dimension or a measure. Okay. In maximum cases, you see smart discovery getting applied on a measure. Guys, for suppose you have a sales model and you run a smart discovery on sales revenue. There is a measure in sales model that is sales revenue. So you run the smart discovery on sales revenue. It gives you all the data, all the details about sales revenue. So all the patterns in the sales revenue data, sales data. Okay, so what factors influencing your sales revenue, or what factors in making your sales revenue go up or go down? Any unusual values? Okay, I'll discuss what is unusual values, and there is a simulation type. So generally it is applied on a dimensional measures. So here you see smart discovery can generally smart discovery runs on the story level, at the story level, on the data model at story level. Okay, it find unusual data, discover the hidden patterns in the data, find the top influencers and contributors on the data. Right, I'll run the smart discovery so that you understand smart discovery, guys. So let me run the smart discovery on this employee travel model itself. I have this employee travel expense model, right? I'll run the smart discovery on top of this model. I'll run it on ticket mode. Let's run the smart discovery and ticket mode. Let's do all the data discovery on ticket mode. Let me open any story. So fare analysis is a proper story. I don't want to touch it, guys. See, here you have location analysis, right? This is like a simple story data with GeoMaps. I'll use this story to run the smart discovery. So in the tools, you see an option called smart discovery. Here you see an option called smart discovery. I'll go with this option. If you want, you can read it out. So here you see the smart discovery is now running on employee travel expense model. So you need to select your target, guys. Target can be either a dimension or a measure, and in maximum cases, see generally what we discover on dimension, guys. Nothing. There is nothing much to discover on the data dimensions, right? So it's easily the measure on which we run the smart discoveries. Okay. So here I'll pick my target as ticket amount. I would like to know everything about ticket amount. Okay. So then you need to select the entity. Entity is like here you see, guys, you must always select target and an entity. Target is the data you want to explore. I want to explore more about ticket amount, so I select the target already. The entity defines the dimensions in which you like to explore in relation to your target and at what level you would like to aggregate the data. So say entity, for suppose, guys, in entity, if I take cabin class, in entity I take a dimension called cabin class, so it will aggregate this ticket amount at cabin class level. If I select carrier code, it will aggregate at cabin class and carrier code level. So like that, in this case, I'll go take travel ID and city pair names, guys. If I select travel ID and city pair names, so no two records will have same travel ID and same city pair names, right? So it's a unique only. Along with that, I select cabin class, carrier code, home office ID also if needed. Origin and destination no need to select because I selected city pair names. You want to see international, domestic, you can select. So this is just at what level you like to aggregate the data. I would like to aggregate the data in the most detailed way. Okay, so I select that entity. Then you want to add any filters, means you would like to see only the data analysis of ticket amount on economy class. You can add filter on cabin class and pick economy. As of now, I'm not adding any filters. I would like to see the overall thing. And then the most important, you got advanced settings, guys. Here you have measures and dimensions. Here you got measures and dimensions. You need to select what measures and dimensions will really impact your ticket amount, because as I very clearly mentioned, right? So when you run the smart discovery, it shows what are the top influences and contributors on your value. So what factors influence? So sometimes, guys, if you select all dimensions and measures, you see some uh, unreasonable dimensions impacting it. So in this case, you need to go and check what factors might influence your ticket amount. You need to select only the measures and dimensions which will really impact your ticket amount. In the measures, carbon footprint impacts your ticket amount, right? Yes. Lost or low fare amount never impacts your ticket amount, guys. So mileage impacts your ticket amount. Lost or low fare amount also impacts. Lost amount is high, ticket amount is also high. Mileage, more the miles traveled, more you need to spend. More the miles traveled, more will be the carbon footprint, more will be the ticket amount. Okay, guys. Generally, this kind of situation we call it as multicollinearity. Okay, see, so generally when you're going for a predictive or data discovery models, you should avoid multicollinearity. Okay, what is multicollinearity is if two or more factors which are heavily related to each other, okay, and they exhibit similar influence on your target variable, so then we call that situation as multicollinearity. I repeat, two or more factors heavily impacting heavily related to each other, okay, show similar impact on your target, we call that situation as multicollinearity. In that case, you select any one. See here, mileage, if mileage goes up, carbon footprint goes up automatically, highly related to each other, and also impacts ticket amount in same way, right? If mileage goes up, ticket amount goes up. Very simple. So this is like a multicollinearity. So generally, multicollinearity should be avoided when you're going for data discovery or predictive models, because you see ticket amount mileage might be the biggest factor, then carbon footprint will become the second impacting variable, like that. So in impacting variables, you see this in first, you see this in second, that's it. So that's the reason if you avoid it, you see only one factor impacting your ticket amount. Okay, it's like that. Even there are some 10 variables which are related to each other and exhibit same influence, pick any one out of 10. If you have 100, also pick one out of 100, that's it. So as of now, I'm picking both to show you multicollinearity. I'll rerun once again. That's okay. So, okay. And in the dimensions, okay, select only the dimensions which impacts your ticket amount. This advanced purchase group has got nothing to do with ticket amount. If okay, I'll select it. So cabin class heavily impacts your ticket amount, right? If you travel in economy class, travel fare is very low. If you travel in business class, high. So very heavy impact on ticket amount. Carrier code also impacts your ticket amount. Some carriers are expensive, some carriers are economic. City pay names. City pay names is nothing but it is also similar to mileage only. Okay, so if you're traveling from Hyderabad to London, the fare is different. Hyderabad to LA, fare is different, right? South San Francisco, fares are highly different. So whether it is a customer related trip or a non-customer related trip, it has got nothing to do with your ticket amount, guys. Okay, if you're going on a customer trip, it doesn't mean your travel fare will go high, right? You can ignore it. So guys, as I selected city pay names, no need to select origin and destination airport code because it covers both. And in general, destination airport code never impacts ticket amount, right? It is origin and destination combination which impacts ticket amount. So that's the reason I selected city pay names. So G underscore country doesn't impact. Home office ID impacts your ticket amount, right? Okay. So travel ID is booking ID. Booking ID never impacts your ticket amount, right? If booking ID is one, ticket amount is high. If booking ID is two, ticket amount goes down. There is nothing like that, right? It depends on the ticket amount in the booking ID is dependent on cabin class, the carrier, the miles traveled, cities, etc. Opportunity ID and opportunity size ID, these are like business opportunities, guys. This has got no relation to the ticket amounts. Travel code, guys, whether it's international or domestic travel, this will impact. International travel, the fare is on higher side, domestic fares are on lower side. Okay. Then you want to see the travel day, whether travel day impacts your ticket amount Monday or Tuesday. You select that also. So travel day bucket that doesn't impact your ticket amount. Even traveler employee ID has got nothing to do with ticket amount, right? If traveler employee ID is 100, the ticket amount is high. There is nothing like that. So I just picked only the factors or the dimensions which I really feel might impact my ticket amount. Okay. So few dimensions which don't impact your ticket amount are excluded from the list. So guys, for better smart discovery, you should properly define your dimensions and measures. All right, let's say run your smart discovery now. So I given all the details and you run the smart discovery. So my target is ticket amount. So at what level I would like to aggregate the ticket amount at this level. And I want to see the influence of these measures and with respect to selected measures and dimensions on the ticket amount. Okay, let's say run. Let's wait. Smart discovery is getting created. Just a moment, please. There you go, guys. You see here. So your overall ticket amount number is $6,942.95 thousand. Okay. So overall, this is your overall ticket amount. Okay, sorry, before I go. So generally, whenever you run Smart Discovery on any measure, guys, it generates 4 story pages. Overview page, key influences page, unexpected values page, and simulation page. 4 pages. Okay, here you see. This is a certification question. So whenever you run Smart Discovery on a measure, this is only on measure. That is Oreo page, key influences, unexpected values, and simulation. These are the 4 pages that gets created if you run Smart Discovery on measure. If you run it on dimension, you see only Oreo and key influences page. You don't see that remaining two. You see only 2 pages gets created. So see guys, Smart Discovery is meant to be created on measure all the time. Okay. So whenever you run any Smart Discovery on any measure on any model, it always creates 4 pages. Oreo, key influences, unexpected values, and simulation. Okay. So you see, a Smart Discovery will analyze your data using machine learning. Smart Discovery, we also call it as inbuilt data scientist, right? It will analyze your data using machine learning. Okay, it runs. You see, it analyzes the data using machine learning. But do you see any machine learning algorithms here? So everything works in the background. Yes, everything happens in the background here. Even though you got some understanding in ML, you don't know what is working in the background. You don't even know what exactly is happening in the background. Okay, that's the beauty of SAC. So using machine learning, create a story page where you can explore the trends and patterns in your data. That is Oreo page. The Oreo page, you can see the trends and patterns in your data. Like you see what's your overall ticket amount. Okay, so number of so this is in thousands. So number of travels happened, that is 6,525. Minimum value is 0, maximum value is 47,000. Okay, so here you see also you see the data distribution. So 6,780 travels has ticket amount range between 0 to 2.94 thousand. 210 travels has 2.9 to 5.89. This is like a histogram chart. This is nothing but a histogram chart, right? So it gives you the overview. Okay, the entire overview of the data, overview of your ticket amount, trends and patterns in your data. This is the pattern. This is your data pattern, and this is your data trend. How your ticket amount has been changing with time. So here I'll go at month level so that you understand this much better. So how your ticket amount has been changing with the time. This is your trend of your data. These are the patterns in the data. And here you see all the top 10 travels based on the ticket amount. Okay. For a ticket amount of $47,000, the cabin class is business class, I think. United Airlines. Travel ID is 43370. Traveling from San Francisco to Frankfurt. So you see all this. So you see all the trends and patterns in your data using in the overview page. Okay, so that's the first page. Okay, then you see on the key influences page, then that is what you see, trends, and you can explore the trends and patterns in your data using overview page. Okay, then depending on your data selection, means what dimensions and measures you selected right before you run the smart discovery. Okay, it will also try creating other story pages. Okay, it will also try creating other story pages that highlight the measures and dimensions that influence your target. Okay, it also highlights the measures and dimensions that significantly influence your target that you see in key influences page. Okay, here you see, guys. Okay, so Kevin class has a moderate effect on your ticket amount. Then you have carbon footprint, travel code, city pay names, mileage, carrier code, lost or low fare amount, and home office side. Okay, here you see this is correlation, system identifier correlation, guys. Mileage, city pay names, and carbon footprint, they all are similar to each other. Okay, so these all are very much similar to each other. This is what we call it as multicollinearity. Guys, multicollinearity should be avoided in your models because it impacts. So you see, while ranking the most impacting variables, right, you see carbon footprint, mileage, city variance, which are very much related to each other. So you need to avoid this. Okay, means if you need to avoid, you need to rerun the smart discovery. Problem is, guys, if I rerun the smart discovery by changing the impacting measures and dimensions, okay, so it will create 4 more pages. It won't impact these existing pages. It will create 4 more pages. Okay, so what I do is, let me delete this first. I want to show the multicollinearity. That's the reason I run this. Okay, now I'll exclude the multicollinearity and run it. So I'm deleting all these pages, all the 4 pages, because it will create 4 more pages once again if you run it. Okay, let's run the smart discovery once again. So run it on ticket amount. what level you would like to aggregate data, you see it here. And in the measures, I don't see carbon footprint impacting my ticket amount. So I remove carbon footprint, just avoid multi-column. And in the dimensions, that's it. I select only the dimensions which I need. Right, I select 3 measures and 7 dimensions, how they impact my smart display. Let's run it once again. Okay, you see the same overview tab. Then I go on to the key influences. So you see, cabin class, the biggest influencer, followed by mileage, travel, port, city pay names. So these are related to each other, but that's okay. I can ignore. This is okay. Carrier code, lost or low fare amount, and home office ID. You see, guys, how cabin class impacts your ticket amount. See, the average ticket amount in business class is $4,500, whereas in economy it's only $600. You see the average ticket amount across cabin class, and this is the number of travels happen. Distribution is number of travels happen in different cabin class. You want to see how mileage been impacting your ticket amount? Okay, so mileage is increasing, your average ticket amount also goes up, right? That's fine. Same, you see, mileage increases, average ticket amount goes up. That's expected. Travel code, how it impacts your ticket amount. Domestic travel average fare, international travel average fares. City pay names. So for carrier airlines, you see the average ticket amounts in different carrier airlines. Lost or low fare amount, it should be missing. Lost or low fare amount increases, your ticket amount also increases. It's expected. Home office ID. You see the average ticket amounts from different home office IDs and number of travels happen on different home office ID. You see all the details, how it impacts. So guys, I'm not worried about this because this is needed for travel testing. So they will go see how different factors impacting the ticket amount and they get some understanding on the data. See, generally, though we might be running the smart discoveries, so it will be more useful for the business users to understand their data in much better way, what factors influencing and everything. Okay. It's unable to load data from city pay names. It's okay, no problems. Here you see in the list A I selected carrier code, guys. In the list B I selected list A I selected cabin class, list B I selected carrier code. So here you see the combination data. So average ticket amount. So in the x-axis you see cabin class which is selected in list A. In the y-axis you see carrier code which you seen in list B, and you see the average ticket amount in no airlines for business class. In one word, sky team and distance. Average ticket amounts in different for carriers in economic class. Here you see the number of travels happen. You see the combination. This is like a combination. Okay, influencing is how they influence in a combination. Right. So this is what you see in the key influences tab. So key influences tab is very important. It gives the business users an understanding on the data, what factors influencing their targets and how they're impacting. Then you got unexpected values, guys, here. Okay, in unexpected values, uh, see, unexpected values means it runs a simple predictive analytics. It runs some simple predictive analytics on each and every record, where it compares your actual value with the expected value, which is predicted value. Here you see ticket amount in actual, ticket amount expected for this travel, difference, and difference in percentage. Means for this travel, guys, in business class, and mileage is 1671 miles. Okay, international travel Warsaw to Frankfurt in Lufthansa, the expected ticket amount based on other travels, guys, should be around $5,000, but it's actually $36,000, and it's just 647% higher than the expected values. So this things gives the travel estimate understanding. So in on what travels they spent very high than expected. Okay, I see someone. If you're not speaking, please mute yourselves. Okay, so this is how the unexpected values work. So this is really helpful for the business users, not for us. See, obviously, guys, whatever you run is for business user only, right? Then we go into the simulation tab, guys. The beauty is simulation tab. So in Smart Discovery, the beauty is simulation tab. Here you see, based on your data selection, it also try creating other story pages. Highlight the measures and dimensions that significantly influence your target that you see in key influences tab. Any unexpected data points in the unexpected values tab. Okay, and then you see the simulation tab. What exactly the simulation tab do? So guys, here you can pass on all the parameters and you see the ticket amount that gets generated. For suppose in future you're traveling in economy class from Dubai to imagine Dubai to San Francisco something. You want to see the mileage calculator. Okay. So if I calculate origin and if I give some origin and destination airport codes, calculate the air distance, it is around 8,100 miles. Maybe let's check the data also, our data also. Sometimes to and fro is different. I'll take San Francisco to Dubai. Mileage is 8,098, acceptable. Okay, it's in miles. Okay, so here I go. Suppose I'm traveling in economy class from here, this to this, so I just take it as 8,098 miles. Travel is international travel. City pay names. Dubai to San Francisco. So carrier, if the carrier is Emirates here, I make lost or lower amount is 0. Home office is San Francisco. Let's say Emirates. So the ticket amount spent will be $1.79 thousand. This is in USD. Okay, 1790, like $1,800 almost. So it gives you here it is $1,400 and $1,200, but this is like 1,800. So the prediction is around $1,800. With the same travel, if I do it in other airlines like something like United Airlines, the same travel is if it is happening in United Airlines, then it is 1.78 only. Okay, there is a decline. So and if the same travel is happening in business class, guys, simulate, you see it will be around 7,000. Okay, $700, $7,800 almost. Right, this is how you see. So what happens is, so it actually says that in the simulation tab, when you change one variable, it shows the impact of a changing variables on your value. So if I change from economy to business, that it will shows the impact of that variable. Means how badly your cabin class is impacted your ticket amount. To decrease your miles, how it impacts your ticket amount. So it's like if you change any value in this influencer, how it is, how this overall number is getting changed. That is what you see in the simulation tab. But one more beauty here is uh, the users can give all the details of the travel and also get some predicted ticket amount on the travels. Okay, right guys, so this is how your smart discovery work. So generally we run the smart discovery is used for all your data diagnosis, understand the hidden insights of your data. So this is like a data diagnosis, right? So we are diagnosing, so if you change something, how it is getting impacted, how different factors influencing your ticket amount. So now you know everything about ticket amount, guys, right? You know everything about ticket amounts. Okay, so this is what we call it as data discovery, guys. Okay, so you discovered everything on ticket amount, and it as it is powered by machine learning, so we call it as smart discovery. So if I use the word smart, that is powered by machine learning. So data discovery powered by machine learning. All right, clear? Makes sense? Anyone? Any questions here on the smart discovery? Okay. So guys, let me run one more scenario on the smart discovery so that you understand the smart discovery in much better way. Okay. Just give me a moment, please. Just give me a minute. I'll be back in a minute and I'll try creating another model and try one more scenario on smart discovery for better understanding. Okay guys, now let's go. Let's create an other scenario for uh, running the smart discovery. So I'll create a proper smart discovery now guys. So I have some employee salary data guys, that was like an SAP standard data I'm using. So I have some employee salary data. I want to run a proper smart discovery on the employee salary. Okay. And give a proper smart discovery where the user can just give the position, the country of origin, and he can give all the details and system will predict him or simulate the expected annual salary so that the HR department can use this, okay, when they are hiring up. Okay, let me just show you the data first so that you understand. Smart assist. So this is some data I got. So employee ID, first name, last name, employee name, which is nothing but an employee name. Okay, gender, department of the employee, office region, office country, and office location of an employee. So you see all the employee details, office details, department details, employment type details, whether it's part-time or full-time, age of an employee, position of an employee, what position he is, and the salary of an employee. So I'm going to make use of this data to create my data model first, and then use the data model to run the smart discovery. Let's go ahead now. Okay, let's first create a data model on top of this file data. So I go to the modeler section. So it is import model, right? So I'll use this option. Here I told you, right, we have four options. Start with data, start with an empty model, via new model type or account based model. So guys, if you have data in files, we always use the option start with data. We always use the option start with data. If you have mass data management and everything and you're pulling the data and doing mass data management, we start with an empty model. So as of now, okay. So as of now, when I say start with the data, um, so in the last use case guys, like when I go for employee travel analysis, I went with an account based model. I went with account based model and started with the data. This time also I'll start with data only because data is in file, but I'll use the option called new model type. I'm not going for account based models, I'm going for new model type, where we import the data first, carry out all the data transformations at the model level. So I'll choose a different path. Okay, so next. So my source is a local file. Okay, select your source file. So you see, so what happens is guys, if you say start with data, okay, in a new model type, here you see age is identified as measure and remaining all were identified as dimensions. Okay, employee ID, first name, last name, gender, department, these all are identified as dimensions and this is identified as a measure. So what I go is first I'll go to data foundation, means data preview guys. First I'll go to data preview. So here I'll, let's say, transform the data. So guys, I would like to concatenate my first name and last name and come create it as employee name. So here you see, I go select first name, last name. Oh, first you need to save it, guys. Let me save this model first. First save this model. I didn't save it up, sorry. Just a moment, please. Just a moment. Sorry, let's go. So, so I create a model now. So I created this employee salary model. Now let's go to data review. Let's transform the data. So I got first name. I also select last name, and let's say apply some transformations on the data. Let's say transform the data. So first, sorry, let's click on transform the data. Here you can apply all your transformations on the data. First, let's apply all the transformations on the data. So this is what you see, right? Like your data preparation tab. This is more like a data preparation tab. So here you go. So guys, it by default creates one version column that is okay. So it is all actual data. If you want, you want. Otherwise, you can keep it. You want to delete, you can delete also. That's fine. The deletion is restricted for this column. I think we cannot delete. That's fine. So it created by default a version dimension, but everything is actual here. That's okay. I don't have an issue. So I got first name, employee last name. See, this version dimension is heavily used in planning. Right? So I'll discuss about this in the planning. Let's go concatenate using space. I'll use option. I'll use this auto session, guys. This is like smart transformation, right? System will give you auto session on the data, which is nothing but smart transformation. I'll use this. Concat your first name and last name. I'll rename this as employee name. Okay. This after concatenation, these things should be removed, right? I still see them. Okay, I see first name, last name, and employee name. That's okay. That's not a problem. I'll delete it later still. Then I have gender, department, office region, office country. Okay, office location, employment type, position of an employee, annual salary. There is annual salary of an employee. If I go to the details, here you see dollar and USD. In this case, let's say I apply a smart transformation. I'll apply a transformation on annual salary where I pick extract. So I say extract number, extract only the number from annual salary after or before after first dollar symbol, I say. So what are the number you see after the first dollar symbol, that will be taken into another column, because I want my salary to be a measure. So I just selected this as a measure. Go to transformation law, details, dimension details. Okay, fine. So I see it perfectly fine. So data type is not string. I give it as uh, salary, right? Is it decimal? Let's check this up. Or integer. It's integer only. Sorry. So I'll give it as integer. The data type is integer. Fine. So I applied two transformations on the data. So one, I concatenated first name and last name and created employee name. And I just, from annual salary, which is having dollar and USD, I just selected only the number part. Fine. Let's say now close data transformation. Save changes before closing. Save all your changes and close your data transformation. So this is like new type, guys. That was like classic account way. Okay, this is like new model type. So where you can apply transformations on the data. And see here, there is data preview, right? Come out of data preview. Now you see all. So these two are identified as measures. Remaining all were identified dimensions. Guys, even age is not a measure. So as it is, as data is integer type, it was identified as measure. I'll change this to a dimension. Here there is an option called convert to dimension. Converted my age to dimension now. So then you have employee ID, employee name, first name and last name. I don't want first name and last name. I can delete this right now. Let's try. Let's go with first name. Let's delete this. Let's check my employee name once. Let's check the data preview once. It is fine. It's showing the data. Even though I delete first name and last name, it's showing the data. It's fine. So I go last name. Let's delete. I delete first name and last name because I concatenated them into employee name. Then I need employee gender, fine, department, fine, office, region, location, country. That is all fine. Region, country, and location, employment type, position, annual salary. Guys, from annual salary, I extracted this. So what I do is I'll delete this annual salary dimension also. I don't need it. Let's edit. So let's go for data preview, cross check once. Salary is showing up, yes. Okay, I deleted required dimensions. So here annual salary I go. Okay, go to the details of annual salary. I select this. Go to the details. So here I rename it as annual salary. integer type. Aggregation type of manual salary, I give it as summation. The aggregation type I give here is summation. So I'm not giving any required dimensions. It will be like a default summation. If you want to run any exception aggregation, you can give it. Salary is based on currency. Okay. So if you have a currency attribute, you can go for fixed currency, that is USD. Or if you have any in any dimension you got a currency attribute, you can pick the currency from the dimension also. Means if you have multiple currencies and you got a currency dimension, you can use it. But here it's a fixed currency. I'll use this variable currencies in the upcoming models. So you want to give any scaling parameter. I'm not giving any scaling as of now because I don't have any understanding on the data. So given all the properties of my annual salary, let's save this model first. Then here, guys, you got office country. If you see the data here, so we can create a level hierarchy: region, country, then city. I can create a level hierarchy here. Guys, to create a level hierarchy, first your dimension, it should be a dimension table, guys. So in this case, what I do, I'll make my office location as a generated dimension table on office location. You want to add any property attributes or hierarchy or description attributes, you need to first generate a dimension table, guys, to add any attribute. So first on office location, I generated dimension table. I see generated dimension table on office location. You want to add any description, you can add some description attributes. Okay. You want to add any parent child hierarchy also. You can add a parent child hierarchy, but I'm going for a level hierarchy, so I create a office location as a dimension table. So, okay. So here I go, office country, convert to a property. I'm saying convert my office country to a property attribute. Target dimension is I'm sorry guys, sorry. First I need to convert this. I'm sorry. Okay, maybe I'll go to the office location dimension table. Okay, I go to the details. Okay, here I can create a property attribute. I would delete the dimension table, whatever is generated. Guys, I missed one thing. On office location, I deleted dimension table. First, what I do is I'll make my office country as a property. I convert this to a property attribute. I convert this office country as a property attribute to office location. Okay. For office location, office country, I made it as a property attribute. Office region also, I convert to a property. For same office location. For office location, I made office country and office region as property attributes. So these two are the property attributes of office location. Here you see. If you close it, you don't see them. They are property attributes. So like this, you can make few objects as a property or text attributes. Okay. You want to add a description attribute, first you need to convert into a dimension table. Sorry, to add description attributes, we need to convert into a dimension table. Otherwise, normal is fine. Okay. In this case, I go to office location. Generated dimension table. for office location, where you add office region and country as property attributes. You want to add more property attributes, you can add here. It's fine. So okay. Right now you have a dimension table in place for office location. If I open the dimension table, so you see these two are property attributes now. I don't have a description. Fine. If you want to write some description, write the same city names and the descriptions. Okay. It's okay. It's up to you. Save it up. I go to the details now. And here in the hierarchies, let's create a hierarchy. I'm creating a level based hierarchy. So here I make my country as level 2, region as level 3. Okay. Hierarchy underscore location. So okay. Save this up. Right. So I may build hierarchy also, version dimensions. You want to maintain any other dimension types, you can change the dimension types here. So I don't have any other dimension types here. Okay, that's okay. So I have all my model ready. So I'll use this data model now to create a smart discovery. So anyway, we are out of time. I stop here, guys. I'll quickly create a smart discovery in the next session, and I'll quickly jump onto smart insights, searched insights, smart transformation, smart grouping. These won't take much time. They all take these all are 5 minutes concepts. If you have some time, we'll start with predictive analytics also. Okay. So I stop here. Yeah, thank you all. So next session is on Monday, regular. Okay. Thank you so much.
Thank you.